Hello and welcome to Chapter 2, Lesson 4, Solving Polynomial Equations in Factored Form. Our essential question is, how can you solve a polynomial equation? So what we're going to learn is how to use the zero product property, how to factor polynomials using the greatest common factor, and how to use the zero product property to solve real-life problems. So example 1, we're going to learn how to solve a polynomial equation. So if you notice in our previous sections, all we had to do is work with polynomials and not polynomial equations. So this now is an equation because we incorporated an equal sign. So the equal sign is what makes this now an equation, and now I have an opportunity to find the solution. Okay, so in order to solve a polynomial equation, it needs to be in factored form like this. So in our previous section, we learned how to multiply a polynomial. So we don't want to do this. We don't want to multiply in because then it's going to be harder for us to solve. We're going to have to refactor it. But we're going to go ahead and start with this. So what I want to do is, what this is saying, this is saying that I'm taking this term and I'm multiplying it to this term here. So I have some number in purple, some number times some number, and the answer for that is 0. So this is where we bring in the zero product property rule. So what that is saying is that if we know how 0 works, right, we know that anything times 0 is equal to 0. So the only way that this equation can be true is if this orange number is 0 or if this purple number is 0. So one of those has to be 0. Okay, so that's how we got to kind of think about this. So one of these has to be 0. So what we have to do in order to kind of solve this polynomial equation is we got to set each of these two terms equal to 0. So I'm going to write two equations. Now this is going to become two equations. We're going to write one for this. So I'm going to say 2x could be 0, right? Because 2x one of these two terms has to be equal to 0. So we're going to have to solve it for both. Okay, what if the purple was 0? What if the orange was 0? So both of these are going to be equal to 0. And then I'm just going to solve these how I'm used to solving equations. So here I need to leave the x by itself. So I'm finding the solution for x. So I'm going to divide both sides by 2 so I can eliminate this multiplication. So I'm going to get x is equal to 0. That is one solution to my polynomial equation. And then on my other piece, I'm using inverse operations. So to get rid of minus 4, I have to add 4 to both sides of my equation, which is going to leave the x by itself. And then 0 plus 4 is 4. And that's going to give me my second solution to my polynomial equation. Okay, so this polynomial has two solutions. So I have x is equal to 0. 0. And x is equal to 4. Right? So those are my two solutions. Let me show you how that works. So if I were to take my first answer, which was 0, and I were to replace the x, right? Replace both of my x's. I would get 2 times 0, which is 0. And then in my parentheses, I would have 0 minus 4, negative 4. So then I would have 0 times a negative 4, which would give me the result of 0. Now, if I were to replace the x on both x's with a 4, right, like that, this would be 8. 2 times 4 would give me 8. And then I would multiply that times 4 minus 4, which is 0. So then that would be 8 times 0, which is also true, equal to 0, right? So that's why we set both parts, both pieces, equal to 0, because both terms could be 0 and make our equation true. All right, so the same thing works when I'm multiplying two binomials. So this is what we have in our second problem. So I have x minus 3 times x minus 9 is equal to 0. So again, we have two things that I'm multiplying that are going to be equal to 0. So some number red times some number blue is going to give me 0. The only way that works is if the zero product property is working. So I need x minus 3 to be equal to 0. So that could be one of the possibilities. Or x minus 9 could be equal to 0. So one of those two has to be equal to 0. So then we're going to solve it to figure out what number for x will make our equation true. So inverse operations, add 3 to both sides. X is equal to 0 plus 3 is 3. And add 9 to get rid of the 9. So then I have x is equal to 0 plus 9, which is 9. So my two solutions for the next one would be x equals 3 and x equals 9. Okay, and that's how you solve a polynomial equation. All right, example 2. Okay, we have solving polynomial equations, similar, right? But these are now multiple steps. Okay, so if I have my first one, I have 2x plus 7, and I have 2x minus 7 equal to 0. So the same thing goes. I separate my two pieces. 2x plus 7 equals 0, and 2x minus 7 equals 0. So I'd use inverse operations. Plus, a positive 7 I can inverse using net minus 7. Subtract 7 to both sides. That's going to give me 2x equals negative 7. Next step would be to divide both sides by 2. So then my first answer would be x is equal to negative 7 over 2. Okay, so that's one solution. This one over here is basically the opposite, right? Because we're adding 7 to both sides, where in the first one we subtracted. We would get 2x equals positive 7. Divide both sides by 2. And I would get x is equal to 7 over 2. So my two answers would be positive 7 over 2 and negative 7 over 2. And the order for these doesn't matter. You can even put them together like this. Negative 7 over 2, okay? Instead of setting x equals 7 over 2, x equals negative 7 over 2, this is also an acceptable way to write it. All right, I'm going to do the next one down over here. Should give me enough space. So the next one I have is x minus 1 to the power of 2 equal to 0. So what this one has is x minus 1 to the power of 2 equals 0. So this still has two things on it, right? This still has two polynomials that are being multiplied that I can set equal to 0. Because x minus 1 to the power of 2 is basically the same thing as x minus 1 times x minus 1 is equal to 0. So that means that one of these has to be equal to 0. But since they're the same, I can just do one of them. So I can say x minus 1 equals 0. I can add 1 to both sides. And that's going to give me an answer of x equals positive 1. All right, so x equals positive 1. So basically what this means is that it has two answers, right? It has two answers of x is equal to 1 because it's squared. So I'm just going to put x is equal to 1 as my solution. It has a repeated solution. All right, and next we have three binomials that are being multiplied and equaling to 0. So I have x plus 1 times x minus 3 times x minus 2, and all of that is equal to 0. So the same thing applies, zero product property. One of these three has to equal 0 in order for the equation to be true. So what I'm going to do is I'm going to set each part equal to 0. So x plus 1 equals 0. X minus 3 equals 0. And x minus 2 equals 0. And I'm going to solve all of them by using the inverse operations. Minus 1. X equals negative 1. Plus 3 to both sides. X equals positive 3. Plus 2 to both sides. And I get x equals 2. So my three solutions, this problem has three solutions. I have x equals negative 1, positive 3, and positive 2. So we have our three solutions, negative 1, 3, and 2. All right, example number 3, finding our greatest monomial factor. All right, so we have a monomial here, or a binomial actually. We have 4x to the power of 4 plus 24x to the power of 3. Okay, so what we're going to do here is we're going to find the greatest common monomial factor. So this is where we're going to need to know sort of our multiplications and to figure out what is the largest thing we can remove or divide from both our terms. So what I want to do here first is I want to start with our numbers. Okay, so I'm going to look at my two numbers and I'm going to think in my head, what are the two numbers? What is one number that I can multiply to get both of these terms? Okay, so I know I can say 2, right? Because 2 times 2 is 4 and 2 times 12 is 24. But is that the largest number? Okay, so what we were looking for is the largest number that multiplies into both of these. Okay, so if you go down the line and you think about it, okay, you know that the number is going to be 4 because 4 times 1 gives you 4 and 4 times 6 gives you 24. Right, so that's the number we're going to focus on. So we're going to pick 4. We can't go higher because there's no higher number that could go into both of these terms. All right, and then next, we're going to look at our x terms. So I have x to the power of 4 and x to the power of 3. So basically, you're going to factor out the smallest exponent one. So because that's the smallest exponent, that's the most that I can take out from both terms. So I'm going to say x to the power of 3 because that's the smallest of the x terms. Okay, so now what's going to happen, okay, is I'm going to put a parentheses, okay, because I'm going to take this out from both of these. So basically what that is I'm dividing it out. So what's going to be left over if I take this out of my problem? So if I take out a 4 from this term, okay, I'm going to be left over with 1, right? Because I'm dividing. So 4, basically 4 divided by 4 gives me 1. And then if I take away 3 of these x's from this x to the power of 4, I'm only going to be left over with just 1x, x to the power of 1. All right, so I'm going to do the same thing. I'm going to divide this out from the 24. So 24, I'm going to divide by 4, which we already established is 6. So I'm going to say plus 6. And then from the x to the power of 3, if I remove an x to the power of 3, I'm going to be left with nothing, right? There's no more x. X to the power of 3 divided by x to the power of 3 is nothing. Okay, so I'm just going to leave the 6 by itself. Okay, and now I have my factored form because I factored out my greatest common factor. Okay, so this x to the power of 3 times x plus 6. I'm removing the 1s because I don't really need them. Okay, this is my factored form of my original polynomial. I factored out the greatest common monomial factor, which was 4x to the power of 3, because that's the largest term that I can take out from both of my monomials in my binomial. Okay, so now we're going to use that idea of factoring out our greatest common monomial to solve an equation. So my first equation is 2x to the power of 2 plus 8x equals 0. Okay, so we have our polynomial equation. And the only way that we can solve a polynomial equation as of now is to have it equal to 0 and to have our factored form. So in order to solve this, I need to first factor out our greatest common factor. Create a product of two terms. So again, we're going to look at the numbers first. What is the greatest number that multiplies into both of these numbers? So if I have 2 and I have 8. Okay, the greatest number that I can multiply into both of these is 2. 2 times 1 is 2, and 2 times 4 is 8. Okay, I can't go larger because 2 is small. And then I'm going to go ahead and factor my greatest common x term. So I choose the smallest one, the lowest. So I have just x, okay? And then I'm going to write my parentheses. What is left over if I divide this out from each of my terms? So what's going to go inside is, if I take out a 2 from 2, 2 divided by 2 is that 1. And then if I take out one of the x's from x to the power of 2, that's going to leave me with just x to the power of 1. If I take out a 2 from the 8, divide 8 by 2, that's going to leave me with the 4, which is there. And if I take out an x from an x, that's going to give me no more x left over. So then I have this as my new setup right here. I have 2x in parentheses 1x plus 4. So now I have this in factored form. So now I can move on to using my zero product property and setting both of these terms equal to 0. So I'm going to set up this one first. 2x equals 0. Or I can also have x plus 4 equals 0. So I took away the 1s again because they're not going to help us solve it. So we're just going to remove those. Okay, then I solve each individual one. So I divide this by 2. Divide by 2. Boom. X is equal to 0. 0 divided by 2 is 0. To solve the one on the right, I need to subtract 4 to both sides. So then I get x is equal to -4. And these are the two solutions to our polynomial equation. So solutions are x equals 0 and -4. All right, our next one is a little bit different. So we have 6n to the power of 2 equals 15n. So I have my two terms, but they're on opposite sides of my equal sign, and there's no 0. So in order to solve an equation by factoring, I have to have an equation that's equal to 0. So what I want to do is I want to put both of these terms on the same side. So I'm going to go ahead and move this 15n, and I'm going to move it to the left. So I'm going to subtract it because it was positive, so I can subtract it. That removes it from this side. So then I'm going to have 6n to the power of 2 minus 15n is equal to 0. So now I've moved one term to the other side, and now I have both of my terms together, and I have equal to 0. So now I can solve this equation, but I don't have it in factored form, right? I have an exponent, and it's hard to solve a polynomial equation when there's exponents. So I'm going to go ahead and factor this out. Okay, so to factor it out, I'm going to start with the number. What's the greatest number that goes into both of these terms? Well, 2 times 3 gives me 6, but 2 times nothing gives me 15. That's a whole number. So I don't want to deal with decimals or fractions, so we're going to keep on trying. So 2 doesn't work for 15. Okay, what about 3? 3 times 2 gives me 6, and 3 times 5 gives me 15. Okay, so that works. Okay, and then I'm going to go ahead and try to see if I can get a bigger number to work. Okay, what about 4? 4 doesn't work for either. 5 only works for 15. 6 times 1 is 6, but 6 times nothing gives me 15. So I think that 3 is going to be our largest number that we can multiply. And then we look at our n terms. And the lowest n term is the one we're going to factor out. So that's n to the power of 1. And then in parentheses, I'm going to write what would be left over if I divide out a 3n. So if I divide out a 3n to the power of 1 from 6n to the power of 2. So first, I divide the 6 by the 3. That's going to give me my 2. So I have 2. And then if I take out an n to the power of 1 from n to the power of 2, I'm going to be left over with 2n to the power of 1. And then from my 15, if I divide out the negative 15 by the 3, I'm going to get negative 5. And if I take out an n to the power of 1 from n to the power of 1, there's going to be no n's left over. All right, so then here's our new equation. I'm going to write it over because I covered that, so it's a little hard to see. All right, this is our new equation now that we've factored out our greatest common monomial factor. I'm going to use our zero product property. Because these are two polynomials that are being multiplied and equaling to 0, I know that one of them has to be equal to 0. So I'm setting it equal to 0. Each piece gets set equal to 0. And then I'm going to go ahead and solve each of them using inverse operations. So I divide this by 3. N is equal to 0. Add 5 to both sides. Divide both sides by 2. So n equals 5 over 2 and 0. And 0. And those are my two solutions to my polynomial equation. All right, that is the end of lesson 2.4. Okay, in this lesson, you should have learned what factored form is. You should have learned about the zero product property, and you should know how to solve a polynomial equation. If you have any questions, comments, or concerns, please let me know in the comment section down below.